curiosity why.
Matrix webcast,
where the human spirit flies. Matrix webcast, where the human spirit flies.
Hey, welcome to the Medbix webcast. No. There's okay. 1 second. Let me before I introduce. Yeah. Let me. Welcome to the Medbix webcast. This is Raman Annam Raju. I'm the host. Technical glitches all over the place, and she's working on it. I think everybody is learning a little bit about this podcasting business. But let me. We have two beautiful women. One is my co-host up here. They waiting for me. She is there's a regular drill. She is a better talking. I have a tagline for her. She's a better talking, better looking, and brilliant. All of them. She's a doctor of nursing practice. She's Susan Davis. She's coming on the podcast. Let me welcome Susan back to as a co-host for this. Susan, welcome. Welcome.
Hey,
How
good
is your
evening.
day?
Oh, my day is better now, Ramona. It's better now.
Yeah. My son used to tell me one time that if there is a war between the viruses and then humans, the virus will win hands down. That is scary part, right? That's where,
They are tricky. They are tricky. They are formidable.
yeah. I have a strange connection to the one of the before the pandemic, before this pandemic, COVID-19 taught us a big lesson, right? And it's not an easy thing. We all learned. I don't know how you survived in COVID-19 as a nurses. Hats off to all the nurses, along with you, and then along with the doctor, all the infectious disease doctors that you and nurses, and you are the frontline heroes to us, all of us. But I want to tell you, I have a very strange connection to the Ebola virus kind of connection. No, I did not get the Ebola virus, but there is a doctor. I'm going to show you a quick video, and then you like a 1 minute video. Then after that, we'll talk about a little bit, and then bring it our guest, Tina Agbaosi. She is an infectious disease doctor. She can shed a lot of light on this subject also. So let me bring that video a little bit. Yeah, that is a video. Yeah.
Hi, I'm Dr. Kent Brantley. Many of you prayed for me in 2014 when I contracted Ebola virus disease while working in Liberia. I wanted to tell you thank you for your prayers. And I wanted to let you know that my family and I are returning to the mission field. This time we're headed to Mukingi Mission Hospital in the northwestern province of Zambia. We'd love for you to join us in prayer and to partner with us as we seek to be faithful to God's calling on our lives. So thank you for praying for us in the past, and please remember us in prayer as our family heads off on this new journey.
At the Tyvek suits to use. We had special made hoods. We had everything that we needed. It was like the game just got stepped up compared to what we were training. And I was like, okay, I think I can do this.
Hi, I'm Laura Spurlock. I'm a nurse clinician with over 15 to 18 years of clinical experience. And I believe in healthcare technology. I believe in innovation, not only for the patients, but also for the nurses.
I'm fascinated by the Locum Tenens app created by Romana and his IT team. One of the features I like about it is it's like Uber for nursing. I can create, edit, delete my schedule before a commitment.
So so Susan, that woman that I know, her very good friend of mine, she's a nurse, took care of Dr. Ken Bradley, first Ebola virus patient, flew to Atlanta, Georgia, Okay, I'm supposed to meet him, and I was, but I was a little nervous. At the time of Ebola virus, is the first patient. There is a they cordoned the entire Emory University hospital system. Is they're cordoned completely up there. It was a Christian missionary. I have a lot of respect for Christian missionaries. They are the frontline workers during the leprosy times, and then during the Ebola virus, or any major catastrophe in the healthcare. They are the Christian missionary. I'm not a Christian, but I tell you, I admire that their dedication to the service is tremendous. But let me bring you from that part of the country, part of the continent at least. She is a Tina. She is a Tina Agbosi. She is the infectious disease doctor. She is joining from Memphis, Tennessee. Welcome, Tina. Welcome to the Medbricks
Thank you,
webcast.
Romana. Thank you, Dr. Susan, for having me.
Yeah, you know that
Wonderful
that
invitation.
let me tell you some small Memphis connection to me before you introduce yourself and give you your credentials and all those things. I was
Okay.
in 9/11 day. I was with your Memphis congressman. Is a good friend of mine, Harold Ford Jr.
Hmm.
I his friend, is a classmate, he used to work for me, and then I was with him during the that time 9/11. I was with Memphis, Tennessee. Harold Ford family is a very well-known family in Memphis. He was a ex-congressman from there. He moved to New York and married somebody. Then he disappeared from Memphis, but he was a congressman from Memphis. He comes on Fox TV sometimes as a Democrat, though. So I have a good connection, and then he invited me to come down to Silicon Valley to talk about computers, introduce computers to Congress people. Congress doesn't know anything about computers. Can you explain to all of us? So I came down with him one time. But Tina, tell us a little bit. That's my Memphis connection. I was there 9/11 day, the day, bad day. It's a very, very strange. I remember that thing. Tina, welcome. So tell us a little bit. Your infectious disease doctor. You are very highly qualified to talk about these dangerous pandemics, dangerous viruses, bacterial infection. You can get up by, they tell us a little bit about your background. Where did you study, and where did you do your residency, and all those things?
Yeah. Excuse me. I'm originally from Nigeria, so I did my medical school at the University of Lagos, in Nigeria, in Lagos, Nigeria, and then I did my residency program, part of it at Cleveland, and then I moved to UT, University of Tennessee Health Science Center. That's where I completed my residency because my family was moving. We were in Ohio for that short time. Um, and I did my fellowship also at UT Health Science Campus at Memphis. So I've been in Memphis since my fellowship. And after fellowship, I went into private practice, practicing as an infectious disease physician, um, with most of my practice inpatient and a little bit of outpatient.
Yeah,
Yes.
yeah. So very good. You know everything about. I just was talking with you about that Ebola virus, and tell us a little bit. After that, I'll let Susan ask you. So, what have you got some? I read your beautiful stories you write on the Medium. It's a very interesting. You write like a storyteller. You are. I was surprised at the way you come across. You when you write. Some people are like that. I can talk, but when you're writing, that storytelling is a very unique gift. You do that very well. So you told us that next to the my hometown is the Silicon Valley. There's Bakersfield. There's a mysterious cases. You wrote about mysterious case in Bakersfield. The guy died with the cancer, and the
Yeah,
virus is a strange virus. He got hit by a strange virus. Um, but tell us a little bit about
exactly.
your. Let us start with the Ebola virus a little bit. What is that, and what did you teach infectious diseases doctor? What kind of a lesson they had from that Ebola virus?
So Ebola virus is a very unique virus, kind of like the COVID virus, that is highly infectious or highly contagious. It is known typically to be transmitted from animals to human. That's usually how the outbreaks happen. Fortunately, we've not had a worldwide outbreak yet, because the world is getting so small, it's getting smaller and smaller. So that there's a possibility that that can happen. But most of the outbreaks are usually in certain parts of Africa, and it's been shown to be connected to probably exposure to infected wildlife. So like people who hunt wildlife, who handle wildlife game meat, and so when they get contract the virus, they are able to now transmit it from human to human through infected contact surfaces. So, and it's very deadly, unfortunately. Um, when someone contracts the virus, most of the management and the care would have to be supportive treatment.
So I heard through the grapevine something about some big news in Memphis, Tennessee today. Speaking of another disease, HIV. I've heard a lot recently about the HIV treatments and the life of people who are living with HIV. It's changed dramatically. But did I hear through the grapevine something very special happened in Memphis, Tennessee today?
Yeah, something really very special, and you're going to be the first ones to hear it. So I've, excuse me, I'm doing work with AHF, AIDS Healthcare Foundation, and they are opening their very first clinic in Tennessee. Today was a grand opening in Memphis, and I'm the medical director of that clinic. And it was really exciting. We've had a big day of celebration. And this is very significant, especially in Memphis, because Memphis, we rank number 2 in the prevalence and new incidence of HIV across the country. And a lot of young people, mostly between the ages of 15 to 24, are the highly most impacted age group being affected by this. So Memphis needs what AHF is providing, and HIV, comprehensive HIV care, prevention services, and they will also be providing primary care for people living with HIV. Because what happens these days, because of the effectiveness of antiretroviral therapy, that is the medicines we use to treat HIV, people with HIV are living longer. In the past, it used to be a death sentence. When you have HIV, you're just like, well, start getting your families together, get your life, your estate together, but not anymore. And I dare say, tongue in cheek, that you're almost more likely to do better diagnosed with HIV than diagnosed with diabetes.
Wow.
If HIV.
Oh
Yes,
That's a
I
death
really
sentence for
wish we could
Indians.
say that. I know. I really wish we could say that more often, so we can get the stigma out from the diagnosis of HIV, because it's really hampering, and I believe, is one of the reasons why we're still dealing with the HIV as a pandemic, as a epidemic, because there's so much stigma. People are not presenting for care, and when you don't present, the whole community suffers because we keep transmitting it. Because with the level of HIV advancement we have now, we have what we call undetectable is equal to untransmissible. So with the drugs that we have now, within weeks, literally within days, and honestly, people become from really high thousands, hundreds of thousands of viral load, that's the amount of HIV viruses circulating in their body, go to undetectable levels, which means that less than 50 copies of the virus can be found circulating. Yes. The only thing with HIV is just we just don't have a cure for it. But guess what? There's no cure for hypertension. There's no cure for diabetes. So people take medicines for the rest of their lives. And if we can get that mindset that take your medicine, come to care, get care, and you would need to be on these medicines for life until the technology advances enough where we can actually completely eliminate the virus from the system. You can literally live a normal life on treatment with HIV and not transmit the virus to other people, not even to your spouse or your partner. So, so it's really great news, because treatment is prevention, and also prevention for those who are high risk is very important because when one person gets care, the whole community benefits from it.
That is an amazing story. You really just brought up some statistics that I would never have thought. I mean, the age group that you mentioned, was it 14 to
Yeah,
14 to 24?
24.
And with this type of medical really miracle, comparing it to diabetes and hypertension. So
Yeah.
I think you pointed out something very interesting. I mean, that stigma is, we had a guest on a week or two ago. We were talking about the stigma behind obesity, comparing the stigma of obesity to
Yeah.
stigma of having HIV. I can't imagine how difficult it is to get people in. But if they knew, why we need to be talking about this more, about how good this treatment is. I mean, that viral load to go down to, what'd you say, 15 copies or 50 copies?
Yeah.
Unbelievable.
Yeah, I used to tell my patients then when I was in fellowship, I tell them, I said, yeah, because they come in so despondent. When they diagnose, they feel so bad because there's so much information out there that's not completely true. And also the culture has kind of blacklisted HIV. And in a way, is the way the infection had presented itself when it was first discovered. So people still have that lingering fear of all what it had cost, the damage and the death and the uncurable nature of it. And so all of that is still happening, but we need to change the narrative and let people know that this is 2025. Nobody has to die with HIV in 2025.
Tina, Tina, I was in Atlanta during the first outbreak of that. I was a kid and going around and selling to the medical devices to the doctors. There's only one doctor, a Jewish doctor, Dr. Aaron Horowitz, unfortunately passed away. He was the only person dealing with HIV patients. Nobody there in the downtown Atlanta, right?
Mm.
I was walking and I seen all kinds of people, black, white, yellow. I saw that I'm walking there. I used to people, they don't know why, how it's transmitted, and still they don't know anything about it. I asked him, are you, no doctor wants to treat the AIDS patients at the time. I asked Dr. Horowitz, how do you handle that? How do you, in your mind, how do you, if I don't, I remember even today, he said that to me, if I don't treat Ramana, who is going to help them? That really struck me as a doctor. Hats off to doctors and nurses. What they do is they jump in the front lines with when the danger comes and danger calling. Yeah, sure. Thank you. Congratulations for your new job, and it's going to be fantastic. Yeah. So, le-
I'm really excited for it.
so tell us a little bit about this. What COVID-19. It's going to come back. You think we are going to be still a hot pot, or where are you? Where we are at that with the COVID-19?
Well, I'll
There's a small question, Romana.
I'll give you my personal opinion of COVID. And I believe it's one of those viruses that it's going to just be around. It's not going to go away permanently. It's one of those viruses that would be coming and probably taking a new identity, taking a new personality each time. Because if the category of viruses in which it belongs, that is kind of what the way they behave. So like those bird flu kind of viruses. So I'm expecting COVID to still be around, but the good news is I feel that over time we might have enough people with herd immunity that it might just end up being like the flu. Like, oh well, you got COVID, you get over it, and you just keep living your life. But just the same way the flu still kills people today, those who are at risk, there will always be an at-risk population that would be affected with COVID. So that's a personal opinion with regards to COVID-19.
So my curiosity is, I know that you study microbiome medicine. So regardless of the infectious diseases we're talking about, so far we've already hit on a few big ones, right? Ebola, we went from Ebola to HIV. Romana comes right in for for the kill with HIV. What can people do? What is microbiome medicine, and how important is taking care of your microbiome when it comes to immunity against some of these bacteria and viruses?
Excellent. Yeah, good.
So I'll be honest with you when it comes to, so from an infectious disease standpoint, as an infectious disease physician, when we were trained or during our training through medical school, I think, and I believe maybe all medical doctors or everyone who's a clinician, that we were trained to view bacteria, the microbes, as the enemies, and we had that mindset to that they cause diseases, right? And we had to figure out ways to either get it ahead of them, but they were always ahead of us, get ahead of them, or at least build something to try to mitigate whatever illnesses they are causing to prevent it from getting out of hand. And so, but and I don't think we've talked about that yet. But in my training as an infectious disease during my fellowship, we were also trained to have a good respect and good understanding of the microbiome, especially within the gut, and how it is very important in the immune system in general. But usually it was more from a standpoint of do not kill the good bacteria when you're using antibiotics. Not necessarily that good bacteria had much more role to do beyond us not just killing them. I don't know if that makes sense.
Yeah.
So just preserve what you have. So because of that, because we've seen adverse effects from people when they take over and take antibiotics that they don't need, or the truth is even in some situations when people take antibiotics they need, they still end up with complications, because that's one of the side effects you get, because in the process of killing the bad bacteria you would knock out some of the good bacteria. So we try to limit the duration, the course, the dose to the minimum spectrum. We call it the spectrum, so we make it as narrow a spectrum to target the culprit infecting pathogen that way, right? But since I've been my interest in metagenomics, I've had a very enlightening understanding and appreciation, a renewed appreciation of the microbiome. And I don't believe this is happening to just me. I feel like there's a renewed interest in the microbiome, and that I feel is because of the technology has become available for us to actually understand what it is. So with the and metagenomics really is the underlying technology that helps with that, because metagenomics, I know you haven't asked me this yet.
That's okay.
But it's a
keep going, because that was next.
It's a very exciting field that is mostly being within the scientific research belt field, but I feel like it's having much more significant clinical application now, where so traditionally when we want to study bacteria, we go out of our way to isolate the bacteria that we want to study. So we will get like a clinical specimen, we wash the specimen, so based on what part of the body, we have an idea, what we call a intelligent guess of if it's a gram positive or if it's a gram negative. So we select the culture plate. So the dish in which we want the bacteria to grow, we actually put nutrients there to enhance the growth of what we would like, what we are assuming is there. So if it grows, we say, oh yes, confirms our suspicion kind of situation. So we work with isolation. But metagenomics has given scientists the opportunity, or the medical field the opportunity, to study bacteria within their community. So there was this illustration I saw online that is like, if you want to study New York, you want to learn about New York, traditional medicine is like getting single citizens of New York to a room and interviewing them one after the other, versus metagenomics.
They're all going to be rude, though. All New Yorkers are going to be rude.
Yes, you just watching, and you can observe them in their everyday life. You see how they interact, you see what is happening with them. So that has really blown up the field with microbiome, and it's so interesting. I feel it was after they did the Human Genome Project that people are suggesting that the microbiome should be termed one of the organ systems of the.
Tina, I think you're frozen a little bit. Can you hear us? You're frozen. Is there something about my? You continue. My system or your system? Somebody can. Oh God. The Navia, who is freezing, and is it my system or their system?
Their systems.
Tina, can you
I can.
send a log out, log in, log out and log in, come back. Both of you log out and log in, come back. Log out and log in. Oh my God. Log out and log in. Log out. Log out and log in back. Can you hear me? Log out and log in back. Yeah, good. Well, I think it is a problem with mine or here in my place. Yeah. 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 Okay. There is a problem there. I think you are frozen, both of you. I don't know what is the reason. Still technology. We are in Silicon Valley, but still technology is a problem. There's no exception.
But it
Tina,
was such a good story, and Dr. Agbaosi is such a good storyteller. So I was like hanging on edge once again for where are we going with this microbiome as a whole new organ, to be
Yeah.
considered as an organ. It makes me wonder and ask you a question of, is there a way to, I mean, it seems like there's gazillions of possibilities of combinations of gut biomes. Is there a way to map them all with your science?
before she answers, I wanted to just say one thing. My friend owns a company. He's a technology executive who opened a company called Biome.com. He's a
Mm.
biome. He's a technology guy. He
Wow.
tests the microbiome. Go ahead and now tell me. Yeah, microbiome. Yeah, tell us how do you test it in a metagenomics testing, or yeah, tell us a little bit about the testing part. Yeah.
That's very interesting because a magazine from Indian that had made I had given a commentary on, they had talked about this. It's called Hack Index. So a research group in India was trying to put up like a map of what a healthy microbiome looks. And that's the
Really?
thing. Yes. So the microbiome is so interesting because it I feel like everyone may very well have a unique microbiome. And that's what makes it so intriguing. How do you know what is normal for each individual? So, even with that said, I feel like that, well, not I feel, it's been shown that there's variations in the pattern of distribution of certain bacteria within regions. So something that may appear to be normal within the Western world may actually be detrimental if present in somebody who is from the East, for instance, right, or from Africa, because it's based on the diet, and there's also environmental factors that determine what the population of the gut you have. And then what's also intriguing is, apart from the specific kinds of gut you gut bacteria, viruses, and fungi you have, diversity also seems to play a role. How much variety of different bacteria you have within your gut seem, at least for now. So tomorrow things might change because it's such a very rapidly changing, because it's so new and it's so refreshing, it's so fresh, and the technology keeps getting better day by day. So right now the understanding is the more diverse the more diversity you have within your gut microbiome is probably more important than having a specific kind of good bacteria where you be like, oh well, I just want to populate this particular kind of bacteria in my gut. But having a more diversity of the good ones is going to be better for you in the short run and in the long run.
Tina, that's I'm going to ask you. Both you're woman. I'm going to, as a man, I'm going to ask you this: C-section and microbiomes. There's a lot of controversy about C-sections done because they lose some microbiome natural. Have you heard about that? A little bit about that?
Well, what I would like to speak to is the newborns have been shown that those who are birthed vaginally, that is how they acquire their first set of their gut microbiome or their microbiome in general through vaginal birth. um, I really do not like to bring up, oh well, C-section versus no C-section, because some situations you really need to have C-section, and babies who are born, they still have the rest of their life to live. And then what also other things that might play into it is if they are breastfed versus fed with a formula. And so all of those things actually will play a role. A child who is growing up in an environment where there's a lot of hyper sanitization versus those who are allowed to eat sand. Not that one is good or better than the other, but it will create a very different gut biome when they're examined over the long run. Yeah.
That's eating sand, eating the child on the playground that's in the eating dirt.
Yeah.
Yeah, eating that. Let us
healthy,
talk
as-
about
healthy as all.
Let us talk about DNA sequence. That's your passion and love. DNA sequencing. I read your, in the columns that you wrote, the story of that you created a character, a fictional character that, like a Forrest Gump kind of character, went through the beginning of the DNA sequence all the way to the USB checking DNA
Yeah.
sequence. It's very interesting. I thought it is the evolution of the DNA testing is just a you beautifully described it. Tell us a little bit about the DNA testing and DNA sequencing, and then story of the DNA very quickly, if you don't mind.
Well, so I wrote that study right out of my learning about it, right? So as I was doing my research, trying to learn more about this whole interesting new field of metagenomics that I just got awakened to not too long ago, I realized that wow, this this um this process has been a long time coming, and there was a time, I think it was it in the 1950s. That was when it was first discovered. And then from there, they had the Sanger method of DNA analysis. And that has been like the gold standard for a long time, up until very recently, that people are actually bringing up other alternative ways. But there are people who are specialists in this field, and I'll let them do the speaking. My own interest in in the DNA analysis and DNA sequencing is really its utility in the clinical medical field, because I see it as a tool. And for me, patient outcomes are very important. Yes. So if there's a tool that would help the physician make better decisions, that will help us arrive at those decisions quicker and help alleviate the patient's suffering earlier, and ultimately lead to a different outcome, which is a more favorable outcome in the patient's disease history, or the trajectory of the patient's disease course, then I'm all about it, all for it. And that's my reason for going into studying all of this, not necessarily just for itself, and not because I see myself going in the lab one day and working, but because out of curiosity, trying to understand this, to me, field that for us that are clinicians it still almost sounds like snake oil, to be honest with you. And that's why I'm going in and studying it and trying to understand it and seeing it from a perspective from the eyes of a clinician. And as I'm doing that, I'm sharing my discovery with my fellow clinicians and hoping that they can come along with me in this journey. So that way we can ultimately have more confidence in these testings, use them, and help our patients. So,
And it's
So,
speed. I think it's speed, right? The miraculous speed of this discovery, the speed
exactly.
the time we get a human sample and we match the antibiotic that's required. So I think the speed in the investigative process is really could be miraculous. And are you getting ready to do your presentation?
yeah, that is going to be very interesting. I want to tell you about that. She's telling snake oil. So science I'm going to present, and when you come back, we will ask you that about that your metagenomics testing and what your passion and a little bit, and then what the infectious disease antibiotic resistance. That's a thing. Actually, I want to tell you a little bit about this is. This is today and yesterday. Very interesting to you, Tina. It's very important to you. There's two things happened today. Yesterday there was announced the Nobel Prize in Physics. It's a quantum tunneling. That if you throw a ball it doesn't go through it bounces back, right? But what these three remarkable individuals, one from University of Berkeley from here, they found out that it is can even the macro objects can go through wall. Very strange way. It's a quantum tunneling they use in the enzyme resistance, all our in our quantum biology. All this quantum tunneling is playing a very role in a bigger role in the future of medicine. In fact, that's a because the delivery of drugs, all those things, they can do the jumping from a lower potential to like a going of water from the bottom to the top. The water flows from the top to the bottom, but in this case it's go to the bottom to the top. That is a
Hmm.
very strange phenomena in quantum physics, but is applying to the macro physics. They won the Nobel Prize, three of them. Congratulations. There is also actually today there was an announcement for it may be interest to you, Tina, that they have a micro the organic metals. They found a new metal that it sucks the RNA DNA in that hole. You administer the contrast, is a contrast injection. You give it to them, automatically it takes that, go there and sucks out the DNA and RNA from there and put in that hole. That's a very strange phenomena. They won the Nobel Prize in chemistry today. In fact, check it out. That's a very very fascinating RNA DNA sequence. But I'm going to talk about a little bit of digital psychedelics. A lot of people in the beginning days of AIDS, every people used to come to the infectious disease doctor and say, I'm so much worried. Give me something mental health. The mental health is a big problem. Can you solve this problem? They said that, I will take the medicines. I will take anything that is a. So mental health crisis became bigger and bigger. People they wanted to prescribe psychedelics at the time in San Francisco is a big thing in psychedelics. But psychedelics is a Schedule One drug. You cannot prescribe under the United States laws. So every country now mental health is going. Yesterday I was still listening. Mental health is a bigger wave than an economic crisis. It's a huge problem. How do you solve it? I tell you, I want to talk about science about maybe Tina can help me in this one. Psychedelics are DMT, dimethyltryptamine, MDMA, psilocybin, ketamine. They're using these kind of things to treat um, but it's not approved. Schedule one, you cannot prescribe. Ketamine, you can prescribe. That's Elon Musk was taking it. That's what they said. We don't know about it. But anyway, one thing they found out is a very strong potential benefits for the psilocybin, particularly psilocybin, which is a mushrooms. There's a depression, it reduces the PTSD and anxiety and addiction. All this one dose, it can stop that. That is a surprising thing to a lot of people. And John Hopkins and in New York Langone Hospital and the University of Berkeley, they're all doing a lot of research on the now psychedelics. But there is a negative side of it. Acute anxiety, it may be come out, it creates anxiety in some people. It is a hallucinations. They become all of a sudden they hallucinate. Aliens and deities. Some people think there is some kind of a devils and demons coming out to them. Higher dimension, some people think is truly we are experiencing higher dimension. That is the that is a psychedelic effect. But I'm going to quantify through physics. Can we do this same experience with the science without substance, without psychedelics? Can we do from Silicon Valley? They love that. They love the mathematics and physics and neuroscience and technology. Use it. Can you simulate the experience of psychedelics? That is what I'm going to present now. So, can we get the same benefits by using math and physics with the technology? Tina and Susan, the future is going to be math and physics are directly going to be involved in the tools of medicine. It's not like a just is a some kind of a side effect. It is going to be direct effect, directly involved in the treating of medicine. This is I'm going to tell you about this, very interesting. So I tell you that the potential benefits, science of psychedelics, I'm going to talk about a little bit. People who take psychedelics, they experience these things. One is priming the brain, contextual. Something his brain does is that when you take a when you take psychedelics, the serotonin, the receptors, they prime the brain. What is a clinical word? Priming the brain is a clinical word. A contextual is that if I say bread, immediately your brain thinks bread, butter, knife. All of them are connected automatically. It's not a searching in the databases. It is searching. That is a priming the brain that he does. The psychedelics does that, prime the brain. Visually, they see a lot of strange graphics. They see weird deities. They see a lot of graphics. They see audio hallucinations. They hear a very strange noises, strange music they hear, and then they feel abstract thing, feeling a time lost and the frozen in the psychedelic experience. Can we repeat that experience through science and medicine? That I'm going to do that. I am that is actually, let me go back, priming the brain. Do you know this? Oh God, I got the wrong one. Actually, priming the brain the is a is a biological is a biological. I think I missed something here. I put the wrong one, I think. Oh yeah, yeah. Anyway, that is let me do. It's a So Matthew Johnson is a biological. What he does is in the psilocybin. What he does is the biological argument is a disrupt the default mode network. That's what it does. It The psilocybin does, the psychedelics does. Default mode network is a effect set. What is the default mode network? It's a filter in the brain. It's a neuroscience. You see so much when you're driving. You see so many cars, so many things. If the brain takes all the visuals, there is no way you can drive. So what it does, default mode network filters off a lot of those things and gives you enough information to drive. That is, so what he does is psilocybin takes that filter off. That's why you get this new kind of a new kind of thinking goes inside your brain. So all the visuals, that there is no filter. Filter is off. Now all the visuals, all the things, without any restriction, they go into your brain and you see all of them. That's the reason it's a biological effect it does. The first one it does. Weird graphics, imprinting. A lot of people said that once you take the default mode network off, the filter is off. What it does is imprinting. Imprinting is a clinical word. What it does is they see a month ago some kind of they went to the temple. They saw something in a strange place. Something is a crystal in the church. It comes back with the default mode network. It comes back and those kind of things reappear in the weird graphics alien, so that the people think it is aliens and all those things. That's imprinting. It does that in the serotonin. That's what the psychedelics do. I'm just talking about psychedelic science. Strange bits, they hear a lot of noises, a lot of strange noises they never heard before. I tell you how it works, those are all. So lost in, people think they are lost in space and time, they're the oneness, they feel like their time is frozen, all those things. How do you replicate, simulate this experience? Matthew Johnson is the scientist in Johns Hopkins, he says, these are all not biological at all. These are all psychological. These are all psychological. Biological is just it's a priming the brain. This is a mostly psychological. So when you are psychological, Silicon Valley can come in because you don't need all this biological stuff. So that immediately, what his argument is so hacking. We call in the Silicon Valley, we call hacking the consciousness. We use the big words though. So we use a hacking the consciousness. They use a no substance used, but we can hack the brain inside the mind,
Nice.
simulate the psychedelic experience, math, physics, technology, and solution. Tina, you want to get in any time, you want to comment, you're free to do that. Or I will ask you at the end anyway, both of you. So how this is a very interesting. You can prime the brain without the psychedelics. You can take a heavy breathing, meditation you do. You can or you can do. My son was telling me today, hey dad, you can do oxygen bar. You can create the euphoria. You can take oxygen. You go to Las Vegas, you get the oxygen bars there. So you can take that. You can create that euphoria, that kind of a priming the brain. Contextual relationships, the databases immediately appear. Can disrupt the. How do the contextual things work? It disrupts the default mode network. That takes the filter off. So heavy breathing, very strange, surprising connection between the heavy breathing and the default mode network. It takes out the filter off for the very surprising connection. Oxygen can do that. You can go to, if you cannot do meditation or heavy breathing, you can do oxygen bar. You can do that. So the next one is graphics. These are the graphics that they see is a very strange graphics. These are only you can see Albert Einstein producing these mathematics. These are negative hyperbolic fractal geometry. These are fractals. They create a fractal geometry. Albert Einstein described the universe through this fractal geometry. When you use those equations, you can produce this kind of a alien graphics, you see, because you don't see negative curvatures on the regular day-to-day life, but you see when you use this negative curvature, higher level mathematics, you can see these graphics, very strange graphics you see. The third one, I'm going to tell you the binaural beats. These are all I learned from Sacred Acoustics. Dr. Evan Alexander is a neurosurgeon. He's on my show for several times, and his wife, his life partner, Karen Noel, she does a Sacred Acoustics. What you do is if you have two frequencies, 250 and 260, has a small difference. Left ear, right ear receive the signals a little bit different. When they find the difference, the brain creates a third beat, a illusionary beat. The beat doesn't exist. This sound is created by the brain. That is called binaural beats, they call. Binaural beats are alpha waves, very slow, relaxing waves. These are all binaural waves. These are, I'm talking about physics a little bit. So, but these are the difference between them. The brain creates a very relaxation music. It creates is not outside, it's inside your brain. Very strange binaural beats are. So that is you use all of them. Then how do you get the lost? How do you feel like time is frozen? Who you are, what you are, where you are, and when you are? What tells you? There is a two Edward and May Moser, both of them won the Nobel Prize for this. They found out in certain cells, a very few cells in the brain, they tell you your location of your hand, location of your head, where are the legs are, where the other people are. Is a graphics. It gives you a beautiful geometrical structure, a GPS system. Time cells tells you if you put a water on the stove, how do you know that when it's going to boil? How do your brain knows? You know already after 10 minutes you got to go and check it out. It's boiling. How do you know? There is a time cells. There are particular cells. They do every 5 milliseconds. They fire a neuron. So your brain knows inside that way of the passing of time, because every 5 milliseconds is one time cell. These are the few cells in the brain. They do this function. They won the Nobel Prize for that. It's a very most unrecognized most important discovery they did in this one. They're all from Europe. So that is an amazing discovery they did. This is the so what do you do? How do you feel time is lost? If you use a VR virtual set, your visual channels are occupied, and then you do the reduce the function of the place grid time cells. When these cells, the place and grid and time cells, they tell you where you are at, what you're doing, when you're doing, that function goes down because visual channels are occupied. Then the time is frozen for you. You feel like you're lost. You're lost in space. You don't know where you are at and what you're doing. That you can achieve through the technology, virtual reality. You can achieve through that process. So he can simulate this experience through the technology and mathematics and physics equations. You can do that. It is a so you feel that MC Usher drawing some of the art you see is a very fascinating art. You feel that experience sometimes. MC Usher, Jackson Pollock, all those people. So brain and spirituality and mind and religion, they're all connected in a way through these cells. You can do now. We have a tools coming up, new era of a powerful arsenal coming to the mental health area, and then the people could use it without using substances. I think I want to be, I want to be in the main business side of it. I'm a business guy at the end of the day, so I wanted to set up these kind of a diagnostic brain cafes around the world and then do all these things in the same place. Then you can really reduce this mental health problem around the world, not in one place. I tell you, this is a very strange thing. We can ask Tina about this. Why there is so much of a mental health pressure going around the world? Maybe infections also going up because of that reason. Thank you for watching. I'm truly honored to present this, but it is a physics and math. That's a Mandelbrot set. So I didn't have time to. Maybe I will do that later on, but let me bring back my guest. What do you think, Tina?
Wow, wow, wow. It all made sense. It all made sense. Because I was wondering where you were going, but at the end, it all made sense. And it's very interesting how you said you were going to bring that to the doctor's offices, to the spas. Because right now, there's so many tools with technology available that we need to use. And that's part of my mission because physicians, or I would say, yeah, medical practitioners, we tend to just um, keep recycling the old ways of doing things. And for one thing, because I always give this example when I was in my ID week last year. When I started out, let me tell a really brief story of how I got interested in
Good.
metagenomics. I was reading a case report in one of the medical journals, and it was a typical, usual, well, mysterious case that we see in encounter in ID all the time, which a lot of times we would make intelligent guesses based on, because ID doctors are known to take really thorough histories, where you've been, all the travels you've been, who you met along the way, how many insects have bitten you, and all of that. And we kind of come up with a list of a long list of diagnoses and then a short list of diagnoses, and then we start running tests. And sometimes we encounter a situation where all the tests are coming back negative, but the patient is not improving based on our empiric treatment. So we'll have to kind of pull something off our hat based on what we found and say, okay, this might be it. And if that doesn't work, we say, well, maybe it's not infectious. Maybe it's an autoimmune problem. Maybe it could be a neural cause of your fever, or it could be something cancer. So we start referring them to alternative causes other than infection. But with metagenomics, being able to literally scan the whole system, so to speak, nothing can stay undetectable anymore if it's infectious. Because when they run the test, it's unbiased, meaning you don't, it's hypothesis free. You don't have to have an idea of what you're looking for. So because it's going to search for all of the available viruses, fungi, and bacteria within the database, and if it's there, it will find it. and you would have something that you can work with, or based on the clinical suspicion, say, well, maybe this is a red herring, right? So this patient was going to take that same path, but for metagenomics, his doctors sent out the next generation sequencing test, and it came back with, I believe that was and it came back, and they were able to make clinical decision that literally overturned his outcome. So he would have eventually ended up dead, but he survived. So that was really striking to me, because I was like, wow, how many people, how many more out there do we have? So I went,
Mm.
because like I was really, it was a mixed emotion, because I've never heard of this test before, and this was just 3 years ago, 2 or 3 years ago. I was like, how come I'm an infectious disease doctor and I've never heard of this test before? Why? And why is it not widespread? Why don't everybody know about it? So when I went for my ID week, I decided to find out what's going on. I realized that there was a divide, and that's why I used the word snake oil, just out, not because I'm trying to be offensive or anything, but clinicians tend to go to clinician meetings. Scientists tend to go to scientist meetings
Mm.
within the same conference. So I decided to go looking to get more information. So I went to some of these DNA sequencing meetings within our
Mm.
ID, and I could not understand anything they were saying.
Oh gosh.
Literally, they were speaking 100% scientific. I'm sure there were no clinicians in that meeting. And then we go to the clinician part of the meeting. We're talking about, okay, sepsis, we're talking about patient care, but we're also talking about the traditional methods, the culture, and all of that. So they are speaking our language, and we're all there. So I'm like, whoa, there's a divide here. How are these guys going to learn about this test when there's this big divide? And that's part of one of my missions, or my main mission, to get the word out there and bridge that. There needs to be a bridge. And that's why I love what you just said. That was one big thing I got about what you said, because you basically brought out something that's seemed really abstract, seemed really scientific, and you brought it down to how it can be used in the clinic. Do you understand how patients can benefit from it? So it wasn't just all, oh well, this is a breakthrough. And they had really wonderful scientific papers they talked about with breakthroughs. But the people who would use it, they were not in the room. Even if they were there, they would not be able to understand what is going on. And that is one of my, like I was saying, why I have I've always had it, because I didn't even realize it, telling stories. Because my medical students who I precept, they will say, how come you give personalities to bacteria? Because I'll be like, well, methicillin resistant staph aureus is a really bad girl, and her cousins methicillin sensitive staph aureus. So I give them I personalize them, or rather, I give them personalities. So, and the students, they get it when I do that. And that's the same way I interact with my patients. And it just comes naturally. And that's what you're seeing in my uh, storytelling.
Your mystery infectious files, infection files.
Yes.
You put on glasses, and here comes a story.
Yeah.
Yeah.
Storytelling.
Wonderful. They're wonderful. In fact, I just was watching your story that was just recently posted on your LinkedIn, a story of a very similar story. It's a 14-year-old boy.
Exactly.
I'm not sure if every story starts with the, fever of unknown, source starts the story. And here we go. The initial testing came up negative, and he gets intubated, right? So he's now
Yes.
induced in ICU, and it looks like not so good. And then here comes your precision, metagenomic testing, and voila.
Exactly.
And he survives, and he goes home, and he has a life. So there you go. I mean, I love your stories, and through stories, you're doing just what you just said. You're taking that science. We talked last week with Dr. Malloy, said the same thing. Scientists need to speak a language that crosses the divide to us, that we can understand what's happening. I mean, so we've talked about some wonderful things in microbiome precision, right? Am I saying that correct? Would you consider this precision medicine at this point?
It is, well, it is what is going to make medicine become more precise. It's so broad in its utilization, but definitely the precision medicine will be riding on the back of the next generation sequencing for sure.
You
Yeah,
know,
better tools, make better decisions, lead to better outcomes.
Outcomes, exactly.
Wise said that.
the bridging, both of you, I have a lot of respect. I'm a physicist. I'm not even a medicine. I never studied medicine. My father is a doctor and a teacher in a small village in India. But, but, that what I learned is when I went to the first cardiology conference, I have zero understanding anything as board. I could not understand even people like Susan walking around everywhere with the EKGs and all those things. Then I have no idea what that means. It's of all foreign language. Slowly then I can connect the physics to it. It's all physics, it's all science, it's all. Then when you connect the bridges, oh God, what is the world will open. The polymath thinking is very important nowadays. We have to think that universal language of that. I'm in Silicon Valley. Stanford is here. Technology, Apple was born here. Google is here. They don't even understand each other. Huge gap in between them. So this is a problem everywhere. If we are the people like you and Susan can solve, and out of interest they can solve this kind of problem, jump in the middle and understanding and create a curiosity to go through the problem. That is a solution to. Yeah. So anything you want to say? Final words, Doctor. So where you're practicing in Memphis, Tennessee, right? You're
Yes.
now you got it you got a job in uh, AIDS Foundation. That's the AIDS Foundation going to be busy for you in Memphis.
So it's a part-time. So I'm working part-time. My primary role as a medical director is trying to help the clinic to stand on its own. And when it's able to stand on its own, hopefully I'll be able to transition out of that role. But my primary work is inpatient consult for infectious diseases. But I do love HIV, and the truth is, I love everything infectious disease.
Yeah.
It just excites me. Seeing patients and doing infectious diseases energizes me. So
And writing the book, telling the stories. Thank you
And
so much.
stories, and not
yes,
only not only the stories, but your newsletter is fascinating too. So well written. So there's everyone listening to us can follow you on your LinkedIn. They can find your newsletter there, which I am subscribed, as well as will be
yeah,
waiting on the edge of my seat for your next infectious mystery. Thank
yes.
you.
Thank you
Thank you
so
so
much.
much. You educated all of us into the world of infectious diseases. We didn't talk about it next time when you can come back.
I will be happy.
Antibiotic resistance. We can talk about it. But thank you so much, Tina. Really, thank you so much. It's truly an
Thank
honor and
you.
privilege to have
Thank
you.
you. I appreciate you.
Really. Yeah. Thank
Fantastic.
you all. Good night.
Good
Good
night.
night.
We are retelling their stories through our patented designs that can be worn on scrubs, t-shirts, printed on conference bags, and endless other promotional materials. Daily Wear for Medicine is the first ever of its kind to create curiosity in medicine through visual art. We at MedBricks are celebrating unsung heroes of the past who made enormous contributions to the field of medicine through our unique campaign called Daily Wear for Medicine. You can wear it, carry it, and give it.